Okay, welcome to the DC-MHS M-DNO practical usage session. I'm proud to be up here today to talk about this topic. As you guys saw coming on from the previous topic, that was a lot of the implementers. We also are several of the folks that participated in the group. The modular density optimized portion of the specification, what we're going to talk about. I'm proud to be up here with my esteemed colleagues, Vincent and Nguyen from HPE and Todd Westhauser from Meta. And we're going to talk a little bit about what the MHS is briefly, and then we're going to get into the DNO capabilities and what advantages and capabilities and facilities it offers. So what is a DC-MHS? Well, it's the data center modular hardware system. It was an industry collaboration in the OCP between AMD and Intel, Dell and HPE. It was Meta, Microsoft, and Google. It has essentially a series of base specifications. There's a host processor module, a couple of those particular specs that are the density optimized specification, which we're going to talk about today mostly, and then the full width specification. From there was several other peripheral specifications that are leveraged in order to build out the rest of the system. The whole concept was to build a series of standard building blocks that allows you to be able to have interoperability, kind of like Lego pieces, if you want to think of it, in order to be able to pull together various systems and simplify server development. So that's kind of the high-level concept. From here, I'm going to let Vincent kind of take you through a little bit of our motivations and the requirements that drove our definition of the DNO spec.
Yeah, so from the beginning, the workstream team member really focused on the use case as the fundamental requirement or the framework to define what the form factor of DNO look like, and also the connectivity, right? What it needs to actually can optimally cover these use cases, including enterprise, the edge, and the cloud. At least from the enterprise perspective, we believe that we need to focus on density optimized that will basically design for energy efficiency as well as for sustainability, right? When you look at that, today the native HPE M-DNO is not comprehend multi-node shared infrastructure. However, part of the new work group that being formed in DC-MHS called shared infrastructure. Within that group, we will definitely define new requirement and also connectivity requirement as from both control plane as well as data plane. And that the outcome of that group will reflect the new type of DNO as well as full width form factor. Along with that, we also look at the head node for storage as and also the accelerator as the use case that we believe will benefit the enterprise segment. Because with the new higher I/O lane coming out from processor, we believe the one socket is likely the optimization for those applications. And for the edge, it's purely, we need to design the form factor that we can optimize for short chassis depth, right? So if you see some of the picture that Dirk will present later on, kind of cover how we're going to achieve that. And I believe that's the two segments I'm going to cover, and Todd's going to talk a little bit more about the cloud.
Yes, my name is Todd, and I'll talk a little bit about the cloud usage. So from our perspective, the really important piece is high-performance compute first and foremost. There's a lot of overlap between that and some of the enterprise, between some of the accelerator options, as well as storage, and any other expansion. So we really wanted to make sure we could use this for a lot of different options, besides just our high-performance compute, but keeping that as basically the core building block. So I'll also talk a little bit more about the specific form factors. One thing you'll notice, I think Corey mentioned in the previous topic, there is no Type 1 anymore. That was something that was an artifact of previous versions that never made it to the final specification. So if you've seen Intel's booth, you've probably seen a Type 2 M-DNO that's actually built up right now. So this is one of the core options we've been looking at, even though there's several different options. This is what we're calling a half-width form factor. So based on a 19-inch chassis, that 210 millimeters is roughly half of that chassis width, and we can fit two of them side by side with a 300 millimeter length. Additionally, Type 3 is also another half-width option, but one thing you'll notice that I'd like to call out is the length is TBD. Based on the development we've been doing and the use cases available as well as cooling options, we weren't comfortable putting a solid form factor there for how long it's going to be, but we do want it to be in that half-width form factor. So we'll talk about this in the call to action, but if you have any feedback here, we're looking for help to help figure out what the right answer is for this particular problem. And then lastly, we have a 3/4 width form factor, which is our Type 4, which can support multiple CPUs side by side in a 19-inch chassis, while still allowing room for some other components such as power supplies or anything else you might want to use in that last quarter width. The last piece I'd like to call out in that picture on the far right is we're trying to integrate all sorts of other specifications that already exist in OCP. So the DC-SCM and the OCP NIC are not part of the DC-MHS subset, but they are OCP specifications we would like to use here, and they're integrated in our form factor to help us move forward with things that we have already defined that are clearly well known and are easy to use moving forward.
And already accepted.
And already accepted. That's a great benefit as well. Additionally, a lot of the connectors you'll see on the M-DNO itself are defined in other DC-MHS work streams, such as the MXIO and the MPIC connectors. So we didn't want to invent the wheel. We're using that across the DNO and the FLW, but they are defined in a single spec.
So this slide kind of give you some of the example in terms of chassis interoperability of different type of DNO, right? If you look at it, you know, the Type 2 had the same width as the Type 4, right? That allows us to basically, if you want to optimize chassis depth design, that you can actually use either Type 2 or Type 4. The benefit of Type 4 is give you more basically I/O as well as more lane and processor core count that can, you know, optimize for accelerator head node, right? So, and then on the other side, if you want to optimize for storage, you can definitely using Type 2. And then from that, you can have more additional storage in front and even on the side to increase the capacity for those type of use case. So as you can see, this is just one of the example of the rack design. I think Dirk will kind of give you some more level of the shared infrastructure for multi-node application.
So I'm going to walk you through a few different examples that we kind of envisioned as we pulled together these specifications, because we talked about the common goals that we wanted to bring together, the common needs, but could we really define a few series of standards that could meet the needs of Meta and the needs of HPE and Dell and the other companies? You know, that's an audacious challenge to look at and try to figure that out. So these are some of the guiding things that we looked at to develop these solutions. You can see on the left, this is all these examples are going to be using an M-DNO Type 2, but we're showing how you can use an M-DNO Type 2 to build an enterprise server that's shown on the picture on the, make sure it's not inverting it left here, and then on the picture on the right, this could be the same board used in an edge type environment or enclosure. We're using all the common building blocks that Todd and Vincent has just talked about, such as the DC-SCM, the OCP NICs, the MCPRS, the MPIC functionality, but this is exactly the same unit that's shared across both of the solutions. A couple more examples. You know, you're looking at a two-node Sled-based server that's shown on the left that has a lot of storage capability off the back. This would be a solution that's optimized highly to I/O and connectivity, but it's still the same core infrastructure that's utilized with the M-DNO Type 2 to build out these nodes. So Todd talked a second ago about the 210 millimeter and being able to put two of these nodes side by side. That's essentially what this is demonstrating, how that can be usable and applicable. One of the other things about the specification we didn't mention was that we designed the specification from the ground up to be able to increase width as well as length of the design. There may be a need that we want to develop something for a 21-inch optimized rack in the future. We're already kind of talking about it in the work streams. So we've got something that'll work across a 19 and a 21, but we've already built that into the specification to allow that future proofing. On the right-hand side, I'm showing an example of a 8-element shared infrastructure solution. This would be a solution that would allow you to use these same blades across in a shared environment, essentially. Now, this is where it gets fun and tricky, and what Vincent has kind of talked about is because you have to be able to manage and control and then also provide data access between these nodes. The advent of things like CXL and future implementations are going to bring forward a lot of new and challenging things, but fun things, I think. It's going to change the age of computing, and we're already starting to look at those things in the implementations we're pulling together. So, as Todd already kind of alluded to, we're not obviating things, we're trying to build. This has been something that we're looking to build towards the future. We've tried to, this example that I'm showing here pulls together a Project Olympus chassis and shows how you could take and build build on that Project Olympus chassis infrastructure, storage-focused rack mount server implementation by using the building blocks that we put together. And this would be a fairly easy implementation to take and leverage the pieces that's already been established, be able to build on those pieces for the future, and pull something together that achieves much greater vision in the future. So, in summary, we have developed a solution that we believe is a implementable building block approach. As I said, that like a Lego approach that is going to streamline development, make companies be able to build multiple systems faster using these interoperability blocks. What we would like you to do is to go and start looking at the specifications, downloading them, reviewing them, and starting to make comments on them, because I'm certain we haven't thought of everything. These guys are pretty smart, but I know we haven't thought of everything.
That's the fact, for sure.
And once you find those things, make comments, send us feedback. We're pretty responsive. The revision 1.0 candidates are available. There's going to be other sessions coming up talking about some of these things later on in the afternoon. Attend those, get more knowledge, get smarter on these things. As we said, I think the show floor closes right after lunch, so if you want to go look at some of these systems, they're up there now. I don't know, Todd or Vincent, do you have anything you want to close with before we open for a question or two real quickly?
No, I think you nailed it pretty well. We're still working on this spec. We have a 1.0 release candidate, but that doesn't mean the work's over. There's a lot of other options we're looking at for future revisions. So please feel free to give comments, feedback, and we'd love to incorporate more things to make sure we cover all the use cases.
Yeah, one thing I would like to add is definitely there will be new type of DNO as well as LW in the future. So we're looking forward for your feedback and your requirement. That actually will help us define the right component for the ecosystem. So.
All right, I think that kind of concludes our presentation. I don't know timing-wise if there's any questions or time for Q&A. I think there may be a minute or two, but given our schedule, but if you have anything, feel free.
Hi, quick question on the feedback. I see you want us to send the feedback to that email address. What format are you expecting that feedback to be in? Spreadsheet, PDF with comments?
We haven't really formalized that feedback. A lot of people have just been sending email. Some have attachments to show their point and what they're looking to do. Once we get that feedback, we actually have a spreadsheet collector that takes all the feedback that as we receive the email and we actually input it into our tracking spreadsheet in the work stream, and then we take action and position based upon that feedback that's brought in and disposition in. So
Thank you.
you're welcome.
Yeah, it's probably going to end up in a spreadsheet one way or another.
It'll end up in the spreadsheet, yeah, but we'll enter it.
Send it in a spreadsheet.
Anything else? If not, I appreciate your time.
Okay, thank you.
Thank you.